solve this equation, then we'll specifically focus on a special solution, y equals 0. So y prime equals ty squared. Let's just separate variables. So remember, this is dy dt is equal to ty squared. Separate the variables. So you're going to have, in other words, dy over y squared. And this is equal to t dt. Now we have to stop and be a bit more thoughtful. Look at this side right here. Something going on there, right? We have y squared in the denominator. Y cannot be equal to 0. That has to be eliminated as a possible value for y. Let's continue from here. So we're just going to anti-differentiate, so dy over the y squared, antiderivative of the t dt, the power rule on both sides, so this is, remember, y to the negative second dy, and then here you have antiderivative of t dt still for now. Okay, now let's apply the power rule, so you can have y to the negative second plus 1 over, let's see, negative 2 plus 1, and then you're going to have here 1/2 t squared plus c. Okay, let's get this into y equals whatever, that form. So you're going to have y to the negative first, essentially, right? Divided by negative 1 is still equal to that 1/2 t squared plus c. Okay, so now we're going to flip. So the next step is allowed by a basic principle that looks like this. Now, on the left side, what we have at first is this, right? You have a negative 1 over y, because y to the negative first is equal to 1/2 t squared plus c. Now we apply a basic principle. So what it means, like, if 2 is equal to 2, then, for example, if you flip it, then 1/2 is equal to 1/2. You see, that's a true claim. So that means you can do this also when you have variables involved. Doesn't change the logic. So you're going to have negative y is equal to 1 over 1/2 t squared plus c. And then just multiply through by negative 1. So y is equal to negative 1 over 1/2 t squared plus c. Lastly, in the bottom there, we have that fraction, so we don't want that. Let me just kind of pop this over here 1 second. You have this. You have y equal to this expression right here. Okay. We don't want the 1/2 in the bottom, so just multiply it by 2 over 2, because that's 1. So you're going to have y is equal to like 2 times negative 1 over, 2 times a half t squared plus c, like this, you see? Because 2 over 2 is 1, you're allowed to do that. And then the y is equal to negative 2 over t squared plus 2c. Really important observation. No value of c, like this, specifically, let me be clear, finite value. If c is made huge enough, then you have to be a bit more careful. But for our purposes, no finite value of c will give us something like, say, y of 0 is equal to 0. Let's try it, okay? So what I mean is this. Imagine you want an output of 0 for y, and then you have negative 2 over 0 squared, so replacing t with 0 plus 2c. Okay, so this condition y of 0 equals 0 is telling us that, right? This is saying y is equal to 0 when t is equal to 0. We are at the origin, in other words, let's say. So then this would be the following, negative 2 over 2c. In other words, then you have 0 is equal to negative 1 over c. Oops, like this. This is not possible. Doesn't matter what c you choose, you can't make that equation work. You can try it. Okay, if you choose c to be a half, it doesn't work. You choose c to be a 90, it doesn't work. You can't have 0 equal to something. Let me stress, right? Why is this present? Because back here, everything that we did relied on remembering that at this step right here, dy over y squared, y is not equal to 0. Just keep that in mind. So visually, what is this telling us? Let me show you a graph or two. That'd be helpful. So visually, look, you can choose whatever value of c that you want. Let's choose some value of c. Say make it 1. So you'd have negative 2 over t squared plus, let's say, when c is 1, you would have 2 times 1, which is like this, 2 times 1. Okay, it's 2. Okay, that gives you this solution. Okay, so then you choose negative 2 over t squared, and then make c equal to negative 1. Why not? So that would be plus 2 times negative 1, like this. I'm just making up a value of c, negative 1. Okay, so that gives you some other solution. Now, if you try to, so the exceptional solution that is not obvious from any of this work is the one that says y is equal to 0. That doesn't work, because look, if y is equal to 0, then y prime is equal to 0, like this. And then that tells us the following. 0 is equal to t times 0 squared, correct? It's when I show the sides are equal and plugging back into the original equation. So 0 is equal to 0. This certainly is true, isn't it? It's kind of the red graph that you see. That is one of the valid solutions, but it just doesn't come out of this expression and the value of c that you pick. I'll leave it at that.